In this video, I'll show you how to solve the ALEKS problem called naming and drawing the products of aldose, oxidation, and reduction. There are 4 different versions of this problem. I'm only going to demonstrate one version, but I am going to talk about how you would solve all 4 of them. So in a few versions of the problem, ALEKS is going to provide you with the structure of a monosaccharide, and it's going to ask you to modify or edit this particular structure to show what molecule would result if that monosaccharide underwent a particular chemical reaction. In this problem, I'm asking to draw the structure that would result if this particular monosaccharide was treated with Benedict's reagent. Benedict's reagent is the copper 2+ hydroxide ion combination. It could be also referred to as oxidation or mild oxidation, and you should be prepared for ALEKS to use any one of those terms. It might say Benedict's reagent, it might give you the reagents, or it might just say oxidation or mild oxidation. What we need to do is edit this structure to show what the product would be if this monosaccharide underwent this process. Now, the product of that reaction is, erase this, that reaction modifies the molecule so that instead of having a hydrogen attached to this particular carbon, there's an OH group. So that would be the only structural modification that you would need to make. Then after you've done that, it's going to ask you to write the name of the molecule of the product of the reaction. So it's not asking us to name the original monosaccharide, it wants us to name this molecule right here. Now the name of this molecule is derived from the name of the original monosaccharides. You're going to want to access ALEKS's data table so that you can see all of the individual monosaccharides and their names. And I've got the ALEKS data table over here kind of pulled up. What we're doing is trying to match the structure of the original monosaccharide, so there it is for reference, match that up with something in the data table, and it looks like what we have is arabinose. I'm going to put this structure back. So we started with arabinose, and what we need to do is modify, or actually specifically we started with D-arabinose, so we need to modify the molecule's name to reflect the structure of this product that's been formed. Now when we are doing this oxidation reaction, modifying the name, we're going to drop the ose off of the ending of that molecule's name. So instead of D-arabinose, we're just going to have D-arabin, and then at the end what we're going to do is add oic acid. So we're replacing the ose with oic acid, and that is the name that you want to put in this box down here, arabinoic acid. Now I do want to kind of say as a side note that in ALEKS's data table, all of the monosaccharides are listed as the D version, even though it doesn't specifically say that in their names. If you had L-arabinose, you would have just the total mirror image of this molecule. So this is what L-arabinose would look like that. Everything in the center portion of the molecule would just be reversed. I want to get rid of all that. Okay, so the other version of the problem where we would be given a monosaccharide, instead of asking us to draw what it would look like if we treated it with Benedict's reagent, it could also ask us to draw what it would look like if it was treated with hydrogen, H2, with something like platinum or palladium or nickel. Or it could say that it underwent a reduction reaction, either of those 2 things. Now, if you get that version of the problem, first of all, what does the product look like? If we undergo a reduction reaction, the carbon-oxygen double bond is modified to a single bond. We add a couple of hydrogen atoms in that spot right there. And to change the molecule's name, we're going to start with the original name of the monosaccharide, arabinose. Again, we're going to drop the OSE off of the ending of the name. And we are going to change by adding itol, arabin. I had an extra I there, it looked funny. Arabinitol. Adding itol to the end of the molecule's name. Now, there is a different version of the problem where you don't start out with the structure of a monosaccharide. In this different version of the problem, the problem is just asking you to draw the structure of a product. So for example, it might say draw the structure that would result if D-arabinose was treated with Benedict's reagent, or draw the structure that would result if D-arabinose is subjected to a reduction reaction. So in that version of the problem, you are going to have to provide the structure of the product. You're going to have to build the whole thing yourself, but you know how to modify the structure based on what we talked about here. You know, if it says, draw the structure of arabinose after it has been oxidized, you know that you need to go to ALEKS's data table, you need to look up the structure of arabinose, and you need to modify it accordingly.